Good evening and welcome to this week's episode of Sunday Night Live, your favorite automotive show where we talk about all those things that improve the customer experience. And I'm always excited when the show comes on because I have this great network and we talk about things that a lot of people aren't talking about. And I'm really charged up about tonight's episode, pun intended, because there's so much buzz around electric vehicles, but there's so much we don't know. I had John Ellis on the show a short time back where we got into it. And I have Eric Smith here with us today, and we're going to get a little deeper into it because there's so much more, especially on the commercial side, things that we may not be aware of at the dealership or some other businesses. So Eric, welcome to the show, my friend.
Thank you. It's good to be here, Paul. Appreciate it.
So tell us a little bit about your background and your time in the space and what brought you here today.
So I did 29 years active duty Navy, submarines, ships, flew E-2 Hawkeyes for 10 years, staff duty in DC for about 9. And then last duty station was Hawaii, where I really got to see, to be frank, Tesla come to the island. But when you're in Hawaii, everything's about sustainability, protecting the environment, and really getting back to Mother Nature. So we were there in 2016 to 2019. We got to watch wave energy become a thing, windmills, solar obviously was very big on the island, whether or not they were going to allow customers to sell back to the grid. A lot of net metering conversations were going on writ large in the market and the industry. Like I said, Tesla came, Model 3 was announced. You started seeing a lot of Model 3s come to the island, a lot of contention for supercharger access. So you started seeing vehicles started lining up to charge. Just so happened, I started a little late in life as a motorcycle rider. So when we were going to Hawaii, I actually looked at motorcycle repair shops, found out that a lot of them had very poor ratings. So I was like, what motorcycle requires the least amount of maintenance? Well, turns out at the time it was a zero motorcycle. So I bought myself a 2016 Dual Sport, which is electric. Became friends with the motor pool crew on base and essentially charged up for free for 3 years. So I commuted on an electric motorcycle in Hawaii, doing my part to contribute to saving the environment. And it was quite interesting because I worked at Pearl Harbor, but I lived in Kailua. So I commuted on the H3 highway up and through the volcano. It was a wonderful time. I also traveled to Asia. So I got to see the use of LEDs, some efficient and different uses of solar and wind. So it really kind of started to compare and contrast what the U.S. market was doing versus some of the rest of the world. And I knew I always wanted to get into automotive, electric vehicles, a little bit of sustainability and climate change. So I started networking before I got out of the service in 2019. I started networking. Didn't really land anything. So I did a project manager role at a fintech for a couple of years. And then just doggedly pursued every opportunity I could to get into the electric vehicle space. So I've been with Ford Pro Charging since the beginning of 2020, beginning of this year.
Okay. And we spoke briefly before the show, and I guess there's some vast differences between residential and commercial, which I'm excited to get into. And it kind of opened my eyes a little bit more as to why some dealers have taken some of the actions that they've taken. So it's kind of cool stuff. I want to get to a couple of comments. We've got Ed Chipolowski. Good evening, everyone. Hey, Ed. Keith Thompson says good evening. And Russell B. Hill. Good evening, Paul. Cannot wait to hear this one tonight. I'm sure Eric has a lot of great thoughts and nuggets. Let's roll. He certainly does. Jerry Davis. Hello, Paul Meijer and guest Eric Smith. I owned an EV once. It was great, but the only way I would have one is if it has a 220 charger at home. And LinkedIn user says, good evening, gents. LinkedIn user, which is my friend Lamont. For some reason, he always comes across as LinkedIn user. As soon as the show ends, it mysteriously changes it from LinkedIn user to Lamont. So cool stuff.
Good evening, everyone.
So battery energy storage systems. Talk to us a little bit about that.
So as everyone understands, electric vehicles run on batteries. So we're facing a little bit of a crisis in the market as every OEM wants to go out and electrify their entire fleet lineup. You need resources, you need minerals, you need a number of supply uh, materials over and above what a normal ICE vehicle uses. So there's a large push on the global market to try to secure that supply chain so that you can bring in those battery supplies and not have an impedance to your normal production cycle, much like we've seen with supply chains over the last couple of years with the COVID impacts, factories shutting down, shipping prices going up 10x in pricing for a container. So same thing in the battery world. You've got a large push for batteries, whether it's going into a vehicle or it's going into a number of other uses. A little bit of what we were talking about before the show started, that battery buffered system. So when you start talking high capacity chargers, ultra fast chargers that usually over 180 kilowatt chargers. So you're seeing some 240s, you're seeing 300s. There's a couple of 350 kilowatts on the market. And people often ask, why the different ratings? Why the higher capacity? And it's all about convenience. You got to put heavy good vehicles aside. So class 6, 7, 8 trucks, put those aside. Like the big announcement with the Tesla semi last week came out. Yeah, it's got a really big battery. It's because it's trying to achieve a range. But at the same time, it's using a lot of battery resources. So you look at that and you say, okay, say for instance, if it has a 200 kilowatt hour battery, you could split that up into 4 Nissan Leafs that use a much smaller battery as opposed to a Tesla semi. So then you also look at a charger, like what we were talking about before the show started. If you have an ultra fast charger who's plumbed into the grid system and it's going to pull 350 kilowatts straight from the grid, that service provider, whoever owns the land, whoever owns the charger and is paying that electric bill, is going to foot a massive demand charge because they're well going to exceed that 15-minute window in that 30-day billing cycle. So that you now have to factor in the much higher cost of electricity. And for some of the listeners, if you don't already know, electricity predominantly changes price under 2 conditions: either time of day for most markets or rate of consumption. So think about it. I was telling Paul, my electric bill last month was about 1,500 kilowatts for the entire month. So if you look at a DC fast charger that's pulling 350 kilowatts just per hour, and most vehicles don't actually pull that the entire time because of their charging curve. But even if it was to pull that, just over the course of a 24-hour period, you're going to well exceed that consumption rate. So you want to put a battery on that. You want to try to curb the peak. You want to bring that peak down to a manageable level, not only from electrical consumption, but just from a pricing that's associated with it. So now you have this big push as we get to a more convenient market where they're putting in much faster chargers, where you want to battery buffer that charger. And so that's why you're seeing that demand on resources. It either goes to the vehicle or it goes to the charger. And then you also have like the Tesla megawatt storage system that's been on a number of grids, international and here in the US, whereby it helps provide frequency regulation for the electrical grid, as well as then any type of brownout or blackout scenario where you could have an emergency backup for certain micro grid portions of the city environment. And so it allows that opportunity of flexibility on the grid. And so everyone is now pushing for electrification of society, electrification of transportation. You're starting to see some of the eVTOLs, the electronic vertical takeoff and landing, convenience shuttle type of opportunities. Same thing. It's going to be a battery. And so there's only a finite amount of resources in the world until someone modifies or improves that technology. They're all going for the same resource.
Now, when you talk about charging, okay, and peak time and charging rates, I guess the way to equate it in automotive, we know about trickle chargers, right? We put a car in a trickle charger if the car is going to be in storage for a while. It doesn't draw a lot, but it keeps it charged. Now, if you had to charge your car at a high rate and you didn't have one of these buffer batteries, then you're going to draw more power off of the grid, at which point your cost goes up. So this battery is almost like on a trickle charger, the way it's drawing off of the grid. Is that a correct understanding?
Correct. I've heard some people refer to the buffer battery as like the toilet bowl, if you will. You hit the handle and it flushes. So
Yeah.
it takes all that electricity and flushes into the vehicle and charges up the vehicle. Well, that, it doesn't fill that tank back at the same rate. It fills at a much slower rate.
Okay.
But that's the same kind of premise, is you want to fill up that buffer battery so that you can pull from it to accommodate capacity based on the charging vehicle, but you still want to try to even out or lower your electrical cost over your entire billing cycle. You never want those large peaks coming in to fill up that tank.
Now, right now, I think our national adoption rate is probably fairly low. What is it, about 5%? Is there a number?
So that's new electric vehicle registrations out of the total, U.S. vehicle market. So yeah, we're just at 6%. I think was the last number.
6% now.
The last quarter.
And companies are starting to go to electric vehicles. Amazon has, I think, a fleet of electric vehicles now.
Yep.
But that's a whole nother ballpark. I think we see electric as, I hear these sales guys come in. We'll put solar panels on your roof, and you'll be selling back power to the grid. But that's a little different than in a commercial application because of
very much so. So a little known fact: while we were in Hawaii, I saw solar panels go up on the local Target. Well, come to find out, Target has actually put solar panels on all of its stores nationwide as part of their sustainability effort, but also because you put enough solar panels on a large store like a Target, you're going to see a sizable change in your electric bill over the course of a billing cycle. And so they realize we can monetize this. Even if we don't sell back to the grid, we can reduce our consumption and our electrical pull from the grid so they become less of a burden on the local grid, but they also lower their monthly operating costs. So it makes sense. It does not make sense at the individual residential level, unless you're willing to spend a lot of money or find some grant or state incentive. And then you've got a big enough roof or enough property where you can put a big enough panel adjacent to your house, because otherwise at scale is the only time you're really going to see a sizable cost savings.
And a dealership has a lot of square footage. So
Yep.
For them, it makes sense to put panels on the roof. And there's at least currently lots of tax advantages to put something like that together. But many of the OEMs are, I see in Automotive News and different publications, they have certain requirements that dealers need to fulfill. And the cost to the dealership may be somewhat different, right, in consumption based on that.
Right. It's just like, and we kind of said we weren't going to talk about my primary job, but, I'll avoid the official policy for Ford. But part of that is much like a conversation with our pro customers. So commercial customers, non-residential, non-retail, is you've got to understand what your billing load is. What do you spend in an average 30-day cycle? And then look at your past year. And that's your best indication of what your electrical consumption load is going to be going forward. At least you can then establish a baseline. And knowing that, like, Ford dealers need to put in DC fast chargers to help grow the network, that's a significant load change. That's going to be a big increase in their consumption. And that is something they have to take into account when they start talking multiple DC fast chargers.
Well, it's GM. It's just about everybody now that going forward with this. Let me get to a couple of comments here. Robert Migliaccio. Good evening, Paul and Eric. And Bill Beezer says the energy storage, aka battery buffered solutions, enable trickle charging from sustainable energy solutions such as solar, wind, etc., further reducing the brown energy required to support EV adoption. Yeah, that's what we're talking about.
Yep. But the beauty of, to your point, with solar panels. So think about country of France. Just recently announced that I think any car park greater than 80 stalls must have a solar canopy of some sort installed. So they're thinking about that aggregate impact to the electrical grid. But you could very well take the same approach to a dealership, depending on the number of parking locations and how big that square footage is. If it's in a very hot place in the in the Southwest, you could provide a shading opportunity. You could also take advantage of it because that's available square footage for solar panels. Much like in the wintertime, you got to clear them off if you're going to take advantage of the sun. But if you put it in a winter environment, you no longer have to then clear off the vehicles underneath it. So there's pros and cons to which way you want to look at how you want to set up your solar canopy opportunity. But really, you've got to think about aggregate and you got to think about it at scale.
I'm thinking that, and I didn't understand this before, but I remember, I think it was about 20% of the Cadillac dealers took the buyout rather than make the investment in electric. So there was probably a lot more to it than most people are even familiar with. And maybe some of these costs went into their decision, is what I'm thinking.
Well, and what a lot of people forget is that, okay, say, we're at 6% of, electric vehicle registrations for the US market. So 97 million, I think, was the last number I saw for the number of vehicle registrations in the US. The number we use at Ford is you're going to turn over your fleet about 10 to 15% per year. So that's still going to take you an average of 8 to 10 years to turn over a fleet. ICE vehicles are not going to go away next week, next decade. They're going to be around for a while. So that's why I think a number of Cadillac dealers probably said, you can keep your electric vehicle. We're going to keep selling ICE vehicles and we'll just step out and become a private franchise. And I understand that approach. Understand, it's thin margins depending on how you cut your pricing structure. We're still seeing that fluctuation in the residual market right now. There was in fact, just today, an article that said that, while used car prices are dropping, the residual value of vehicles are still remaining quite high. So it's changing the dynamic of who really does have that pricing advantage when you go into the market to look for a used vehicle. It's going to be interesting because, December is always that wonderful month of the year. If you're looking for a new to you vehicle, even if it's a used vehicle, December is the best time to do it. You got end of the month, end of the quarter, end of the year. Everyone's trying to hit their quotas. But it'll be interesting to see how much leverage the buyer has going into that deal when they're looking to buy a vehicle.
At Lexus, December to remember was always the big sale at the end of the year. So it'd be interesting to see what happens, going forward here. Kimberly Gray says solar panels on large buildings is brilliant. What I see also is I see a lot of solar panels, like in Massachusetts, for instance, just in the fields, like these fields and fields and fields of solar panels.
Yep. Now, the biggest problem that, I'm a voracious reader, so I spend a lot of time both on LinkedIn and I have a curated Google News feed, mostly with electrification issues. So, and I forget where it was, but to your point, I think it was in the Northeast. They've got somewhere on the tune of 18 months of backlog for interconnection regulatory filings for customers asking for permission to connect to the grid for exactly that thing: solar fields, solar factories, solar farms, whatever term you want to use. It's the same thing. It's solar panels at large scale in an aggregate manner that need to connect to the grid. I mean, that's the only reason most people put a solar farm in place, is to sell that electricity as a electric provider to the grid. You throw it on the market. Whether or not you have one customer who comes in and says, I'll buy all your consumption for the next year at an agreed upon power purchase agreement, or whether they wouldn't put it on the open market, someone's going to buy that green energy because that supports a lot of the sustainable goals that a lot of corporations are going after lately. They need to be able to justify their carbon offset, whether it's actual quote unquote green energy or just some sort of effort to buy down their carbon footprint on the market.
Did you say a year and a half? Did I hear that correctly?
A year and a half, about 18 months of interconnect filing requests just from customers who have a number of aggregate projects they're trying to bring onto the grid. And so the state, and like I said, I think it was the Northeast, was basically trying to figure out how can we streamline this process, go with those customers who are either approved vendors, approved installers, they've got a reputable track reputation, so that they can basically say, okay, yeah, we're going to trust that you've done everything correctly, and they're going to approve the interconnect so that they can then get to the more difficult request and actually do their due diligence before they allow it to come onto the market, onto the grid.
So are people or companies then waiting 18 months, or are they building them on spec, figuring that they're going to get approved for this?
Well, that does change the conversation, because that's the most frustrating thing. Like when we were in Hawaii, we were very fortunate. We've rented. The landlord he had 8 siblings. One of his siblings was a general contractor on the island of Oahu. So he had told us when we moved in, he's like, I've always thought about going solar. We have already put in the application. We've got the permission. We just haven't pulled the trigger on installing it on the house. And so I kind of had to talk with him. I said, hey, we're looking at, I already have an electric bike. We're looking at getting an electric vehicle. If at all possible, knowing what the cost of electricity was in Hawaii at the time, it's like, I would highly encourage you to do it, because it'll only become a lure to increase your rent for, the next renter, not me, hopefully. But, it's a selling point for either the rental property or the house itself to put solar on. And so he was like, all right, I think I'm going to do it. And he called his brother, and his brother called me like the next day. I was like, oh, I thought this was going to be like a week, maybe a month. He's like, oh, no, we've got it in stock. Solar's a hot thing in Hawaii. So then, no kidding, came I think it was 2 days later, put solar on the house. And then the waiting time was to get that grid connection authorized. So even though he was pre-approved, it still took another week, 2 weeks, I think, which is relatively quick on the retail market, because otherwise you could wait a couple of months. And so think about it as a consumer. I paid thousands of dollars to put solar in my house. It's going to offset my electric bill and or make me feel better about protecting the environment, because I'm becoming less of a consumer, more of a producer. But I have to wait for the state, local regulatory official to come out and say, yeah, it looks good. Electrically speaking, everything's according to code. It's safety. You've got your interconnect in place, before you even just turn on the switch and take advantage of production from the sun. And that is the most frustrating thing for a number of people, because especially if you're talking about a large solar farm where you're aggregate, thousands of kilowatt hour production, that's money that's just getting wasted because it's getting produced. It's just not going anywhere. You're not being able to sell it to the grid until you get that interconnection in place.
So in the home use, let's say, if you had solar panels and you had the battery, you could use it. You just don't get the sell back benefit.
Correct. And that's the way Hawaii actually started to go. So we were there, 3 years. We got there in 2016. Net metering was authorized. So average consumer could sell back any electricity that their solar panels produced over and above what they consume. They could get a bill credit from Hawaii Electric, HECO, that would show up on their bill. And then once a year, their account would rectify, adjust, whatever the term was. Basically, HECO would zero out the compensation, and then you'd start over from scratch. You couldn't keep banking in your favor solar credits, if you will. And that was HECO's way of adjusting the books. Well, by the end of 2018, HECO said, oh, well, hold on. Too many of you are putting solar on your house. We can't keep giving money to all you customers. That's not our business model. We sell you electricity. We don't buy your electricity. So they started to reverse their policy. They changed the time of use during the day. They changed the rate at which they paid for that solar electricity that customers were being reimbursed for. And then eventually all new interconnects were told, you can put solar in your house and you can offset your consumption, but we're no longer paying you for the electricity you put on the grid. And so it's interesting because even as recently as last year, 2021, early this year, Florida was one of the first states to actually go out and say, we're going to charge you extra if you try to sell electricity back to the grid from your home mounted solar panel, because you're creating more of an imbalance on the grid than what we as Florida Power and Light provide to all of our other paying customers. And so it's an interesting way to take the Power Regulation Commission and manipulate or influence, whatever term you want to use, and discourage customers from putting solar on their house.
Wow, it sounds very close to a pay plan change at a dealership when
It,
you
it
start doing well.
it was interesting because, you think about the small guy and the average, residential customer who's like, I just want to lower my electrical bill. And yet now you're going to make it so it's regulatorily challenging. Why would I even spend a couple $1,000s and put solar in my house if it's going to be more of a headache? I'll just keep paying Florida Power and Light.
Wow, talk about squashing a business.
Yeah, it's interesting. It's not resolved, and if anything, it's starting to spread to other states too.
Now, talk to us a little bit about the minerals and the resources. Where does all that stuff come from, and how much of there is it?
So the ad hoc numbers, because I specifically try to avoid reading into that, comes from China. I think it's like 87% of some of the critical minerals that we need in batteries come out of China. Lithium being one, because they use those on the anodes for the connection points of the batteries. And then a number of your other raw materials just come from various mining facilities around the world, which is why you're starting to hear undersea lithium mining. You don't know about the quality, but it's still land on the sea bottom. So it's a matter of, can you dig it up? Can you refine it? Can you put it in a usable format and contribute to the mineral market? The other aspect is there's a couple of like heavy metal fields in the U.S. that have just kind of been roped off as I forget what they call them, but super tin. That requires so many more resources from the U.S. government to actually clean it up that it's usually just a roped off section. Like nobody's allowed to go in there. We're not going to do any business here. We're going to rope it off, try to keep it from leaching into the groundwater or any of the other areas, and just not use it. So people are starting to look at that as, what if we could clean that up? What if we could find usable material in there and clean up that resource environment? So they're trying to find alternative sourcing to the traditional electric vehicle production side. It's just like we're seeing with Redwood, who is a former Tesla engineer who said, hey, all these electric vehicles are eventually going to drop below a certain threshold. So it's about 80% for an electric vehicle battery for cars. And then it's about 60% threshold usable battery life for battery storage. So grid support, chargers, buffering, that type of thing. So when it drops below 80%, you take it out of a car, you put it in a storage system. When it drops below 60%, you take it out of the storage system. And you're like, what do we do now? Well, Redwood was actually set up to recycle and reuse battery materials. And now that they've done that enough times and then sent them back to electric vehicle OEMs to use in their vehicles or into battery buffered systems, they're starting to realize those reusable recycled battery designs are as good or better than original OEM batteries. So you're truly getting into a full, reduce, reuse, recycle type environment where it's like, oh, well, this is a good thing. It's no longer as bad for the environment as we thought it was because we're now reusing a large majority of the original design battery.
So it's not. So we saw it initially as, yeah, we have to get these resources and we're limited, but at the same time, the batteries have so many lives, so to speak.
Yep.
That it sounds like it makes up for that, or a good portion of it.
I mean, thankfully, the beauty of ingenuity in the American market is it's just a matter of what you can think of. And hey, I wonder if this is a feasible idea. Let's try it. And then you start to realize, oh, there's actually a market for this. There's a way we can make this a feasible thing. We can find the business model where it supports growth and opportunity. And they just then put it up at scale. And you start finding customers once you build it.
So from the car batteries are I think what, 10 years, 150,000, or 10 years, 175,000, depending on manufacturer.
And that's a U.S. policy to protect the consumers.
Are they lasting that long? Or are they lasting that long, or is it too early to tell?
Well, Tesla is the only manufacturer who's actually getting to that 10-year mark, who's starting to see what's lasting. Of course, they've also been changing their battery design, the makeup, the chemistry. You're starting to hear conversations about mixed battery chemistries within the same vehicle. So you have like an ultra capacity, capacitor type battery chemistry on one side, where it can take a very fast charge, but then it can slow trickle charge the deeper cycle battery on the other side. So you're starting to see people who look at the same challenge of providing a usable range to the consumer. That's all the consumer really wants. They don't care what the battery is made up or how it's designed. Can I get 300 miles? Great. That's the car I want. So you start to see this change in the chemistry. And back to the original point is, Tesla's been around since 2001. So they've started changing it up. Sorry, I misspoke, 2010. So we're at 12 years, but you're still seeing a number of older model Teslas, higher mileage Teslas that have been changed out at least once or twice on their battery. But it's because it hit that 80% threshold, or there was some other contributing reason that Tesla said, hey, we're just going to go ahead and change the battery under warranty. But they learned from that process. And yeah, the rumor is that Elon Musk is working toward a 1,000,000-mile battery. If that means you can have a battery that stays above that 80% threshold for 1,000,000 miles, it doesn't matter how many years it takes you to get there. You're covered for 1,000,000 miles. That's a lot of road time.
And that's got to be a lot of cost too, no?
No. Once you do it at scale, you don't necessarily need to mark up a premium. On the Tesla vehicles, it's usually the trim model you hear about, like it goes like a dual motor, which is all-wheel drive. Then you get a performance version, and then you get like a plaid and all these goofy little names that Tesla throws on it. But they can find other ways to mark up that. But really, the battery chemistry is fairly consistent across the model line. And then it depends on where the vehicle is sold. So in China, I think I had heard that they're not considering the lithium ferrous LFE battery in China because it's a relatively new technology and China doesn't want that liability. But they're already considering bringing in that battery to America because consumers are okay with getting 220 miles as opposed to 300 miles. All it means is you've got a less energy dense battery. It's cheaper to produce. It lowers the price of the vehicle. So from a dealer standpoint, you open up that margin for the dealer, but you're lowering the purchase price or that price to entry for the consumer. So therefore, they just look at the vehicle as being $5,000 to $10,000 cheaper. So yeah, I'll take it. Okay, so I give up 10, 15% of range.
Well, the funny thing is that in studies, I think the average person drives less than 250 miles per week anyway.
Yeah. And you break that down, whether it's 40 miles a day, 60 miles a day, depending on what you use it for. It really does go back to a little bit of what we had talked about before this was for the average user, they don't know what their electrical consumption is in their house, what their electrical consumption is in their car. They don't know what they drive. And really, when you're plugging in your car, once a week, twice a week at your house or wherever you park your car overnight, you kind of lose track of what you're actually driving because your car's filled up, ready to go.
Right, and you can charge
like
it over.
My dad, who tracks mileage on his odometer every time he fills up the car. I don't know how many electric vehicle drivers do that.
Probably less than zero.
Yeah, I mean, like I said, when it's a full tank every time you leave your garage, do you really care how many miles are on it?
And you can charge it slow overnight, and you're sleeping anyway.
Yeah, exactly. And when you look at the use case of a vehicle, and this is where the argument for Uber and Lyft come into play and autonomous driving, you truly can put a vehicle fleet out there that is self-supportive because you don't need a driver. You don't have to wait on the human factor. Some would contend, that's a liability because it has a slower response time from an automated number of sensors. You then have a fleet that you can have a lot less vehicles still servicing the same number of, passengers. Presumptively, they're all humans, but the point is whether you call it Uber for your kid to get to school or you call an Uber because your car's in the shop, you just need less vehicles because there's more availability on the open market.
Want to get to a couple of comments. Kimberly Gray says, my brother has a solar field in northern Kansas. He never has an electric bill. He sells his extra to the grid at discounted rate. They give him credits. When he needs to use those credits, he is charged full price for electricity. I guess it sounds like their way of curving the price.
Yep. It was kind of like HECO, like I said, they won't let you bank those credits. They're going to zero it out once a year.
Yeah,
but if you never pull a consumption and everything is generated on your roof, you kind of don't care about banking the credit. You just, are planning to the point that you're never going to have a high electricity bill for the life of the time in the house.
Joe Chambers says, hey, everyone. Joe Chambers is one of my SDL guys, along with some of the other folks on here, Jerry Davis, Robert Magliaccio. We get together every Sunday morning at 8 a.m. Eastern time, and we talk about fixed ops things that affect the stores and how different people resolve those issues. So definitely reach out to Joe for the link. If anybody on here is not on that Sunday morning call, it's one you definitely want to be on. Now, fast chargers cost money. Do you know, is there a certain, do you know what the percentage is of people that have those fast chargers in their homes, or are most people still doing the standard slow charging?
Okay, well, let's get to terminology. So most people call level 1 your average AC outlet. Little known fact for most of the people in EU, that home outlet is 220 volts. So inherently, they're just going to get a higher amperage charge in a shorter period of time. Here in America, we're at 110 volts for level 1. Level 2 is a 208 or 240 volt, or sorry, 208 or 220 volt, but usually higher amperage. So, for instance, I have a Volkswagen ID4 in the garage. I have a level 2 charger. That's a 40 amp charger. It charges in about 2.5 hours, regardless of when I plug it in. However, it's a smart charger because I plug it in and it turns on 11:01 p.m. at night, which in the Georgia Power service area is my EV time of use rate. I essentially pay 1 penny per kilowatt consumed between 11 p.m. and 7 a.m. But that doesn't mean it's going to run the entire 8 hours. Like I said, it's only going to take about 2.5 if I ever fully depleted the battery. And most EV drivers don't. Back to your earlier point, they just don't drive a lot. In the wintertime, you'll see a drop in range because of chemistry. And, much like human body it gets kind of lethargic in the cold weather. Same thing with electric vehicles and their batteries. It's still a liquid. It's still a medium that gets very viscous in very cold weather. So it needs to heat up in order to operate better. But so then once you get above level 2, the misnomer is it's not really level 3. It's technically DC fast charge. But actually, level 2 can go up to 80 amps, so 19.2 kilowatts. Once you get over 20 kilowatts, maybe even 25, 30, that starts to get that little fungible window between, okay, is 60 kilowatts really the minimum of DC fast charge? I think there's actual technical definition in the ISO rating. I just don't have it memorized offhand. So most customers who have a convenience of living in a non-street parking environment, so they either have a parking pad, a carport, a garage, etc., have the ability to wire that level 2 charger for convenience where it can charge overnight. But otherwise, if you're stuck with 110 volt, I think it pulls 8 amps, maybe 12 amps, depending on your wiring. That can take a long time to charge, and it may take longer than 8 hours overnight. When we were renting our house and I had a Nissan Leaf, I could never get a full charge at home unless I wasn't driving for a couple days. But when you go to work every day, that's hard to do. You start looking for workplace charging, even if you have to pay for it. At least then you can really top off that battery once or twice a week.
Now, with depending on where you live, with solar panels, there are different tax credits. Are there any type of tax credits with the chargers, the fast chargers, level 2s?
It depends on your electrical provider. So when we switched from the Nissan Leaf to the Volkswagen ID4, I did treat us. Georgia Power was running a deal. I think the charger we bought retails for $700, but Georgia Power gave you a stipend of $250. So, hey, that's quote unquote free money I'm already a Georgia Power customer. So why not just buy it through their marketplace and get a reduced price for the same capacity charger? It
So
really depends on the electrical provider.
So the chargers you buy right from the electrical provider?
Yeah. Yeah. I just went on, it's called the Georgia Power Marketplace, much like you can buy LED lights, um, electric vehicle charging equipment. I don't really know what else you can buy on there. I know they have a number of preferred vendors if you want to service your air conditioner or heater, switch over to a heat pump. Because you got to remember, electrical providers are still in the business of making money. They
Right.
sell you electricity, and anytime you want a service upgrade or an increasing convenience for you as the consumer, you're going to pay for it.
And a lot of times, when you're installing these in your home, if you have an older home, you're looking at upgrading your electric service.
Absolutely. Yeah. Especially if you're like at a, God forbid, 120 or maybe even 160 amp capacity. In most modern homes, people are usually at capacity. So if they want to put in a level 2 charger, they're going to look at upgrading that 200 amp to a 400 amp service, which means you got to hire an electrician. You got to request an electrical upgrade from your service provider. So a number of regulatory and permitting issues. It's not an immediate process, and it's definitely not a cheap process.
So if you own that cutesy Victorian that was built in the early 1900s that hasn't had any upgrades, this might not be for you.
I can recommend a company called Beam Global. It's a external solar panel with a heliostat that follows the sun, and you just put that in your parking pad outside your house. That might be cheaper at about $45,000 than it would be to upgrade the electric in your house.
Yeah, I was going to say that. I know that gets very, very expensive. Now, alternative energy sources, wind, wave, nuclear fission. Wind seems to make sense to me, but yet I hardly see it anywhere. I see in New Haven, which is about an hour from my house, I see 2 wind turbines. Going to Rhode Island, which is another hour plus in the other direction, I see by a college there are 2 or 3. I forget the exact numbers, but I don't see a lot of wind turbine. Is there much of that tied to this?
It's a little less predictable, obviously, than solar is. Solar, based on the angle of the mount and the time of day where the sun angle is going to be. So solar is very predictable. Wind, not so much. In certain areas, wind will pick up at the end of the day. Wind will pick up overnight, obviously, depending on weather, whether or not you have a mountain range nearby, whether you're adjacent to the ocean. That's why you see a lot of offshore wind power, because out in the ocean, you tend to get steady breezes in certain parts of the world. And that's why you see, congregations of like along the Northeast coast, off the coast of Europe. There's a number of fields where they put up massive, and we're talking 350 feet high windmills. So just the blade length alone is a sheer capacity. But you're also talking about megawatt ratings on the electric. So then they run a cord from that to a substation type of facility, where then it can basically be plumbed back to land and service all the adjacent, usually, residential areas nearby. But you're talking about thousands of homes at that point for these large, massive windmills. It was interesting in Hawaii, a number of the other islands, so like the Big Island and Maui, they had windmills, but it was almost always on a ridgeline. So you got the wind, predominant prevailing winds coming in one direction. So why not put all your windmills right along that ridge line? Because then you have a steady stream of wind.
So the windmills are more commercial applications.
Oh, very much so. Yeah. The one residential application was a proof of, a proof of concept a couple years ago, and it actually looked pretty aesthetically pleasing. But there's a number of, imagine, micro turbines, if you will, so about the size of your hand, and it was a couple hundred of them in a flat pane, if you will, that you could basically like mount beside a house, or think about it, between houses you've got a funnel. You could put this panel there, and because all these micro turbines are aggregated, you might have something similar to solar on your roof, just if you don't have a good orientation for solar panels. this might be a viable alternative. And it truly was a proof of concept. I haven't seen it on the market being available for, what the pricing would be at the consumer level.
And is that similar as well insofar as buffer or battery storage for to capture that?
I'd almost, tongue in cheek say you're better off getting a transparent solar panel on your windows.
Okay.
Again, it's such a new technology. It's not a proven reliability that for the amount of money you spend to install it, you're probably not going to recoup your break-even cost anytime soon.
Well, if they're looking for a place to pilot it, I would suggest Aruba, because there's always winds in Aruba. There's so much so that there's a tree called the Divi tree, and the tree itself is on an angle that's almost 45 degrees because of wind. There's always windy there.
That's why they put umbrellas in their drinks, right?
Yeah. Wave. Talk to me about wave energy.
So it was pretty impressive. There's a Hawaii Pacific University had a number of satellite offices around the island of Oahu. And one of our favorite beaches over on the windward side, there was a pier. So a number of the locals would go fishing on the pier. But adjacent to that pier, they had 3 essentially pontoons that were mounted on articulated arms and a piston attached to the eave jump. So waves, much like solar, is very predictable. You're going to have waves coming in, high tide, low tide, very predictable. People have charted it for years. And so you mount this at just like the median height of the ocean. And you know that when that wave comes in, it's going to push the pontoon up because it's essentially air inside of a vessel. Yeah. And then when the wave goes out, it goes down. So when it pushes up, it pushes that piston. So whether it's pumped liquid, so imagine like a hydroelectric pump who's recouping that pushing motive force from the piston, or then when it drops down, when the wave goes out, you get that reverse suction, if you will. So it's a matter of you connect that to a pump. You now have a hydroelectric production facility, and the motive force is truly the height of the ocean as it comes in and out via waves. And it was neat to watch that operate essentially 24/7. Once you get it in place, you just do your preventative maintenance, but otherwise you've got a reliable electrical provider.
I want to get to a couple of comments. Bill Beezer says, curious if you have seen any battery buffer solutions for level 2 charging.
I have not, Bill, but I go to a once a month meeting here in Atlanta called the EV Club of the South, and listening to a number of the memberships, they're usually Georgia Power employees from years back who just keep meeting once a month to talk about change in technology. One of the gentlemen in there is such a he's very aware of his electrical consumption to the point that I would almost opine that he's a big V2G, so a vehicle to grid advocate. But he does have batteries in his house specifically for buffering from the solar panel. But it's almost a nuance, and this is why I say I haven't really seen it that often, but he talks about charging he has a Tesla and I think a Chevy Bolt, and he charges it from the battery in his house. Now, the battery is primarily there for solar, but it's still available electricity that you can essentially dump into the battery in a vehicle. So it's not intentionally for level 2 charging, but it is available. And the same thing you see with a Tesla Powerwall in people's garages. Usually it's because they have solar, but there's a good chance they're driving a Tesla vehicle too. So you can charge your vehicle from the battery, especially during time of use. Like for us, it's 5 p.m. to 9 p.m. on a weekday during the summer, because that's when people come home from work and turn on their AC. You could charge your vehicle from that battery as opposed to pulling from the grid.
Now, when you have your set up so it goes on at 11 o'clock, when you plug in your charger, does it know that it's going to start charging at 11, or do you have to like select charge?
Like everything else, it's an app. It connects via Wi-Fi to my house, and I just program it ahead of time, so it's got a pre-programmed schedule. And the reason I did that was, to be frank, the Volkswagen infotainment system is very poor. Even the Volkswagen CEO recently admitted to it's going to take a few years to fix it. It's unfortunate, but my Nissan Leaf scheduled charging in the vehicle was so much more reliable than the Volkswagen ID4 that when I traded in, at the peak of COVID, traded in my Nissan Leaf and We had ordered the ID4 and it came in. I got flustered with it so much. I was tired of walking down at 11:05 at night just to plug in the car. But I turned off the in-vehicle schedule because it was so unreliable. So like I said, when Georgia Power was running a deal on a level 2 charger, I was like, this will save me having to go down and plug in the car after 11. I'll just get a charger that can schedule it via the app and not have to think twice about it.
Yeah, that's great.
The beauty of Wi-Fi these days, there's so many things that are all about convenience.
Oh, tell me about it. Kimberly Gray says, I sell commercial chargers and negotiate with utility companies, can obtain permitting, active installers, and am NEVI qualified and have Blue Oval Ford approved products. Can, say, an old Tesla battery be used for battery storage of excess residential solar and windmill energy energy produced?
I would say, Kimberly, you could use any battery for just about anything. It's a matter of your controller. And a number of people have proven that you can get open source software on the web as opposed to having to program something from scratch. But really, that battery management system is the same premise, whether it's a vehicle or a off-grid storage system. It's a matter of how you charge the battery and then how you discharge it.
Battery size. Now, I've seen the Tesla ones mounted in a garage. Is the battery the entire size of that shape, or is that a part of it?
You usually show, I don't know the inner workings of the Powerwall, but I would surmise that it's probably the average vehicle battery. Like, whether it's a blade, a prismatic, or a pouch, they took whatever that form factor is for a standard battery in a Tesla vehicle, and then 2x, 10x, whatever to size the Powerwall. And the beauty of the Powerwall, having seen them in person, is they're relatively thin. They're not that thick. Yeah. You can actually stack them, if you will. So you put it in a garage, you really can kind of line them up all along the side of the garage and not take up a lot of the parking space.
Yeah, no, I've seen them. They're very narrow.
And I'm impressed. They're just very pricey. And unfortunately, like our house, we're on a northeast southwest orientation. So it's not ideal for solar. So looking at a break-even cost of the average production rate, it just didn't make sense for us. It would be somewhere in the 22 years to get a break-even on a solar installation. So I've been watching cost of residential batteries to see if that is a viable alternative, because we're paying peak pricing between that 5 p.m. and 9 p.m. in the summer when we run our air conditioning. Now, the way to look at it is kind of like what we've touched on earlier, electrification of society.
Right.
Heat pumps are a big push from the Biden administration right now. If you have the money and the time and you're going to be in your house long enough, switch your HVAC system over to a heat pump. You can run that 90% of the year and have a significant reduction in your consumption load. And then a battery is no longer a concern.
Now, batteries. I used to hear about electromagnetic fields, but it seems like that conversation just gone. Is that because it no longer exists, or
EMF? So right hand, the 3 rule. You've got this is really pulling back old knowledge, Paul. Thanks, but EMF only happens when you have amperage movement through a cable. So proper shielding of most cables for electrical code, you don't have to worry about the EMF interference.
Whether it be in the car itself or in the house.
Right. No, I mean, especially in the cars, that's the biggest thing. You have to have FCC compliance, is you're going to properly shield everything. Because the last thing you want, if you remember, a few years back, people were concerned when cell phones first came out. Oh, I don't want to fry my brain. I'm going to hold this up next to my head. I'm going to get brain cancer. There was a very small legitimate reason for concern, but in the big scheme of things and the amount of power that antenna was putting out, you're not, they basically said you'd have to be on the phone 24/7 for a couple of years for that to even start to be a concern. And most people were never going to have it in that, range of usage. And then of course, now we have, Bluetooth AirPods. So that kind of removes that cellular antenna concern. So no, part of the FCC compliance is always making sure the human is foremost protected, but then interaction and interference with other vehicle type of safety concern. So it's going to be a well shielded.
I think most of the brain rot comes from social media today.
Oh yeah, you get in that death spiral of scrolling, doom scrolling.
I think that the curse is those, what do they call them? Those little videos. The 30-second, oh, you can make this dish yourself at home.
Yeah, the snippets, those little TikTok videos.
The reels, yeah. Got a couple of comments. Let's see here. Bill Beezer says, interesting, thank you. And Kimberly Gray, great, thank you. And Ed Chipolowski, is all this opening the door for liabilities since high voltages will kill you if you're not properly trained?
It is a very real concern. I've heard the conversation from the auto tech standpoint is you want to make sure you train your technicians appropriately and have certain safety precautions in mind. Anecdotally, it's not the voltage that'll kill you, it's the amperage. All it takes is 0.1 amp, so not quite a milliamp, to stop the human heart. So you can be high voltage shock as long as you don't get that current flow through the heart. But yeah, it's still a concern. You see an orange cable, the biggest thing for most technicians, orange cable means high voltage. So don't mess with it unless you have a reason to. And then if you have a reason to, make sure you have your safety precautions and your gear on hand.
Wow. One milliamp, you said?
Yeah.
That's like nothing.
Yeah, exactly. So, holding that 9-volt battery on your tongue, it'll hurt and it'll shock, but you're not going to get a high enough amperage flow through the heart.
Huh.
Don't go out and, put a 9-volt on your tongue, Paul.
No, at this age, I'm not looking for anything that's going to cause me any kind of discomfort or pain.
Yeah. There's other ways to get excitement, like having a conversation on LinkedIn on Sunday night.
So everybody, all these manufacturers are saying, oh yeah, we're going to be all electric by 2025, by 2030, by 2035. How realistic is that in your opinion?
I think 2030 is realistic. I think 2025 is robust unless you're looking at severely cutting back on your product line. I mean, even so, BMW is, in the market, people said the BMW was great because they started the i4, the i3, the i8 was a hybrid. It was a pretty cool looking car, but the i3 was really the big market mover. It was super high price though. And then they kind of backed off on electrification for a number of years. Well, now they're starting to come back out. They're starting to incrementally electrify certain model lines in their vehicle lineup. I don't remember what their end game is to electrify the entire lineup, but they're being methodical about it. And I think that's kind of where you need to look at most OEMs is really where are their high profit lines, right. Usually luxury, usually high end saloon type of vehicles. Obviously now in the market, in the U.S. market, you're seeing a lot of trucks, a lot of SUVs, big vehicles, but it's the same thing. We tell our customers, like at Ford, not every battery electric vehicle perfectly meets your use case. So it really comes back to what the consumer and the average driver of the vehicle wants. If it's not an electric vehicle, then look at a hybrid, look at alternatives. But I think most OEMs are not going to be in a true electrified, sole source electrification of their product lineup for at least by the end of the decade.
And ICE vehicles are going to be around for a long time, unless they come out with some kind of equivalent to what we had with cash for clunkers.
Well, and it's funny you mention that because I was on this kick a couple years ago where I really felt like Home Depot and Lowe's should do a cash for clunkers for 2-cycle gas engines, lawnmowers, because those are the biggest polluters. They don't have catalytic converters and they're 2 cycles, so they never fully combust a full fuel load in the motor. And they make just an awful lot of noise and exhaust and fumes. So why don't they go out and try to electrify the lineup? I mean, there's a lot of 40-volt options that are on the market now, but to your point, no one's getting rid of their gas mower tomorrow because, well, it's paid for. It's easy. I can go get a couple of gallons, fill it up, and be fine with it. Or like most consumers will say, well, my 2-cycle motor is not going to kill the environment tomorrow, so I don't need to change it out until it's worth my while to get an electric mower.
That 2-stroke Briggs & Stratton motor in your lawn boy literally burns oil.
Yeah.
Every time you use it.
Yep. Every time you fill it, you fill it up once a month, you got to put a little thing of oil in there.
Yeah. But it'll go forever.
Pretty crazy. Yeah, I'm a big Ryobi advocate. I was a little late to the party, but once I switched from an 18-volt mower to a 40-volt mower, haven't looked back.
Really?
Very capable mower.
Wow. Well, Eric, thank you so much, man. The hour comes fast on the show.
It does.
It really does. There's so much information, and we've only scratched the surface on what else is out there. But my goal is always to get people thinking that, hey, give them some more information and get the conversation started, because it's not only is it coming, but it's already here. And with all of the push that I see, I think they're kind of forcing adoption on us. So it's going to come quicker than probably a lot of people are ready for.
The beauty is that if you have the money and the means, there's an electrical solution for just about everything. And most people, once they, especially from an electric vehicle standpoint, once they drive or own an electric vehicle, their next vehicle is going to be electric too. It's just, it's more fun. It's more convenient. It's less messy. It's easier to maintain, lower operating costs going forward. There's very little detractors unless you're a hardcore greenie who say, well, we're stripping minerals out of the earth and we're damaging Mother Earth. Yeah, okay, there's a little bit of validity to it. But on the whole, you're reducing your operational expenditures and impact. So why would you not want to do that?
Very interesting. Couple of comments before we close. Joe Chambers, great show, fellas. Thank you, Joe. Appreciate it. And Ed Chapolowski says, do you foresee license requirements for EV technicians such as required for residential and commercial electricians? That's a great question.
They do. They already have it. I would recommend you go look at Volvo. They're one of the first OEMs to require it of their technicians. And there's actually a Cal State course where you can get certified as a EV auto electrician.
Any others?
I heard Ford talking about it. I don't know when their university is going to come online. I heard it was going to be in 23. I just don't know what quarter. But it is a concern. They want to make sure that you have properly trained and certified technicians. So if nothing else, you can vouch for your own product lineup, let alone other electric vehicles.
Well, I think Volvo has probably the most aggressive plan for electrification of their fleet.
Well, and they've come out with the Class 8 semis already that have been in play for a couple of years now.
Cool.
So that you also have the Polestar lineup and the brand new Volvo C40 and XC40 that have been out for a couple of years too.
Andre Henderson says, got an Ego 56-volt mower, best purchase ever.
Yep.
Cool.
Plug it in. It's ready to go when you need it.
Eric, thank you again to everybody that watched, whether it's live now or on the replay. A lot of people watch it on the replay. Thank you very much. Appreciate your support every week. And we'll see you next week on Sunday Night Live. Thanks again.